Hello and welcome to today's lesson. In today's lesson, we shall be looking at modular arithmetic. This is your instructor, Mr. Alfred Gordon. Our learning indicators for today's lesson. Undertake a brief review on sorting and divisibility rules of integers and determine their connection to modular arithmetic using models such as number arrays. We shall also model simple situations involving modular arithmetic concept, connect the ideas to real-world problems, and solve them using appropriate models and technology. Now let's begin. What is modular arithmetic? By definition, modular arithmetic, often referred to as remainder arithmetic, is a mathematical system where an integer is expressed by its remainder after being divided by another integer. The key concepts: we know numbers wrap around upon reaching a given fixed quantity, that is the modulus, to leave a remainder. For example, the days of the week wraps around. We begin from Monday and then we come back to Monday again. Now we also see the calendar month also wraps around, because when we begin from a particular month, say January, we come back to January. And then the clock time. So the clock time is circular, okay, so we get back to the 12-hour cycle. Now notations and definition. Notation. So for modulo, we shall see A mod B, where the mod here is representing the modulo. So A is an integer and B is also an integer, which is neither 0 nor negative. Now this represents the remainder when A is divided by B. So this here represents that, then give us the remainder when A is being divided by B. So the results of this will give us the remainder. For example, 31 mod 7. So for 31 mod 7, what we need here is that now when 7 divides 31, okay, what remainder do we get? So let's do some quick mathematics here. So 31 divided by 7, we know 31 is same as 28 plus 3, all divided by 7. But we know that 28 is divisible by 7, therefore the remainder is 3. So we can see that then this will give us 4 whole number, 3 on 7, meaning that our remainder is 3, and that is what we need here, and that is what you are seeing here. Good. Now finding remainders, that's method 1, using the repeated subtraction. Now this method repeatedly subtracts the modulo number until you cannot subtract further without getting a negative number. So the first one, we have 7 mod 4. So we are going to subtract 4 until get a negative. Yes, so we have 7 minus 4 to give us 3. Okay, but when we do 3 minus 4, we're going to get a negative, therefore 7 mod 4 is equal to 3. Okay, also here we have 9 mod 4. So we can see that 9 minus 4 will give us a 5. But here we have the chance to subtract again. So 5 minus 4 is equal to 1. But you see, subtracting 4 again from 1 will give us a negative. So it means that 9 mod 4 gives us a remainder of 1. Okay, we can also do the same evaluation, okay, by finding remainders. That's the method 2, using the division. So this method says that divide the number by the modulo and identify the remainder. So if we have a divided by b, it's going to give us a certain integer q as a whole number. Then we have the remainder over the denominator, where b is the quotient and r is the remainder. Then a mod b is equal to r. So let's try this example. So with this example, we can see that 7 divided by 4 is going to give us a one whole number, 3 on 4, meaning that our remainder here is 3. Okay, let me write another example here for you. So let's have a 12 mod 5. Now for 12 mod 5, 12 divided by 5, okay, can be written as 2 whole number, okay, 2 on 5, meaning that we have a remainder of 2, and that is 2. We can also have 18 mod 7, which is 18 divided by 7 will give us 7 divides 18, say 2 times, okay, remainder 4 on 7. So the remainder here is 4. So remainder 4. Good. So that is what we are dealing with here. Okay, so examples of basic modulos. So example 1.22. 7 mod 4 is 3. That's the remainder after dividing 7 by 4. Also 2 mod 10 gives us a 2. 2 mod 10. Okay, we see when we begin to do our first subtraction, we are going to have a negative, which we don't need. Okay, so we don't need to subtract to have a negative, therefore our result is just 2. So here we don't do any subtraction here. Okay, now we have 9 mod 3 is equal to 0, and we can try that here using repeated subtraction. So 9 minus 3 will give us a 6. Okay, we can subtract, so 6 minus 3 will give us a 3. Yes, so we can subtract, because 3 minus 3 will give us a 0, but subtracting again will give us a negative. So 9 mod 3 is 0. Okay, and lastly we have 81 mod 5. So 81 mod 5 is equal to 1, because we can write this as 81 also divided by 5 is equal to, so 5 divides 81 how many times? So 5 divides this, we say that is a 1 time. Okay, and we have a remainder 3, so we have a 16 whole number, 1 over 5, meaning that our remainder here is 1. Good. Now, hints for finding modulo. Hint 1. If the dividend is less than the divisor, okay, then that's the modulo number, then the dividend remains the answer. So here, this is the dividend and this is the divisor. So whenever you find that the dividend is less than the divisor, in other ways, the divisor is greater than the dividend, then the result is the dividend. So here we have 1 and then we have 5, but we can see 1 is less than 5, so our result is 1. We can also have a situation like 7 mod 8. We can see that 7 is less than 8, therefore the mode here is 7. Okay, now hint 2. For modulo 5 of numbers ending with 0, 1, 2, 3, 4, that means numbers, the ending numbers are all less than 5, okay, and they are whole numbers. So the answer is the last digit. So like 12 mod 5, here the last digit is 2 and it is less than, it is part of this set members, so our result is just 2. You can take your time and then do that using repeated subtraction. So subtract 5 from 12 and you are getting a 7, and then go ahead and subtract 5 from 7 and that will give you a 2. So you can as well go through that and you have the answer. Here 170 mod 5, okay, since the last digit here is part of the set element, then our result is just the last digit. Now hint 3, for modulo 5 of numbers ending with 5, 6, 7, 8 and 9, all we can do is to subtract 5 from the last digit. Okay, so we don't want to be wasting time here. So with 19 mod 5, okay, since 9 is greater than 5, okay, and then we can write this as, so we just consider the last digit, so we consider the last digit here, okay, and then we subtract 5 to get the modulo, and that is 4. You can take your time and then go through that using repeated subtraction or using the division method. Now divisibility rules. Now we said divisibility by 2. If a number has its last digit to be an even number, okay, like 0, 2, 4, 6, 8, then that number is divisible by 2. For example, we can have 42 has a last digit to be 2. Can have 384, last digit is 4. We can have 210, the last digit is 0. So far as the last digit is part of these members, then it is divisible by 2. Another is that divisibility by 3. If the sum of digits is divisible by 3, then yes, the number is divisible by 3. For example, we can think of this number as 42. Okay, when we do 42, we can see 42 is 4 plus 2, which is 6, but this 6 here is divisible by 3. However, it is a multiple of 3, so it means that 42 is really divisible by 3. We can have other examples as we can have 36. Okay, now we see 3 plus 6 will give us a 9, and 9 is divisible by 3. So yes, 36 here is divisible by 3 as well. Now divisibility by 4. If the last two digits form a number divisible by 4, then that number is really divisible by 4. For example, we can have 144, okay, 144. The last two digits here is divisible by 4. Therefore, the entire number here is divisible by 4. We can have 2, 5, 6, 2, 4. The last two digits here is 24. Since the last digit here is divisible by 4, then the whole number here is divisible by 4. Another is divisibility by 5. If the last digit of a number is 0 or 5, yes, then the number is divisible by 5. So any number I write here, so okay, I write 100, the last digit is 0, divisible by 5. I write 125, the last digit is 5, is divisible by 5. So any number I write with the last digit 0 and the last digit 5 is divisible by 5. Now let's jump to divisibility by 9. Okay, you say that if the sum of digits is divisible by 9, then really the number is divisible by 9. So for example, if we have a 36, yes, we know the sum of 36, the digit is 3 plus 6, giving us a 9, and 9 is divisible by 9. Therefore 36 is divisible by 9. Okay, so we can have a 333. Okay, will also add up to give us 3 plus 3 plus 3, which is also what, 9. So far as the sum of the digits is 9 and is divisible by 9, then the entire number 333 is divisible by 9. And lastly, divisibility by 10. So any number I write which has a last digit of 0 is divisible by 10. Okay, so I'll pause this video here and we shall continue our discussion on Modulo in the next video.